If we just step back for a moment and look at some of the history, when railways were first developed in North America, customers were charged by the railway by the carload, whether the car carried feathers or whether it carried bricks, they paid by the carload. It didn't take customers too long to realize that this wasn't a very fair system based on the different commodities. And the only equitable way to correct that would be to weigh the loads. So the very first thing was to develop a system for weighing cars. So here you can see a very, very old piece of rolling stock. I'm not even sure which railroad it's for because I don't see any reporting marks on it. But other than a car number, it doesn't obviously include any lightweight or capacity data. But there's a number of things that can influence the light weight of a car. Certainly snow, rain, and debris, as you can see on these covered hoppers in Terrace BC. And anybody in our part of the country that's done much snow shoveling this past winter knows exactly what I'm talking about, that the weight of a wet snowstorm could certainly influence the light weight of a car. But of course, there's other things that could also influence the light weight of a car. Through some research and studies, they found that an inch of rain could even temporarily increase the weight in a hopper car of coal by up to 1,600 pounds. Of course, that was temporary because the water would eventually drain out through the hopper pocket doors, but it did influence the car if it was weighed when just after a rainstorm. Here we see a Canadian National gondola with a clean floor. This is what customers would like to see being placed into their operation, but rarely is this ever the case. This is probably more likely what's being delivered to the mill. You can see here that this particular car has some wood dunnage left over in it, perhaps some steel plate, I'm not quite sure, maybe some plywood, and definitely some dirt and other debris that could influence the light weight of the car. In some cases, customers would even turn these cars away and refuse to load them. Here's just another example of a dirty gondola floor. This one maybe not quite as bad, but there is a certain amount of debris in there that would need to be cleaned out. But the railway also benefited from the use of track scales because now they could ensure that the appropriate locomotive was assigned based on the gross tonnage of the train. So that was also important to the railway. So not only were the customers being charged the correct amount for the product that they were trying to move, but the railway also had appropriate locomotives assigned to the train. So there's a few scale definitions that we should just review so everyone's aware of them. Capacity is the nominal load in pounds and cubic feet or gallons if it were a tank car. Load limit is the combined light weight of the car plus the maximum loading based on AAR ratings. And of course, the light weight, which is the empty or the tear weight of the car. In this first photo, you can see this CN 40-foot outside braced boxcar, and down in the bottom left-hand corner, it says 7.27 new. That indicates that in July of 1927, this car was weighed at the manufacturer's plant, and the light weight was stenciled on at that time. This car actually looks like it's in pretty rough condition. I'm really surprised that it had not been reweighed sometime during its career. Here's a CP 40-foot ice reefer with an underslung alcohol heater, but you can see where the red arrow is pointing that this has been reweighed. It's stenciled AN 1056 or Angus Shops in Montreal, in October of 1956. Cars were typically weighed when they were brand new. They were weighed again within 15 months. This was particularly true with wooden cars because the wood did deteriorate over time. Then the car might be weighed again within 30 months, and after that, approximately every 4 years. Today, cars are rarely weighed more than every 10 years, as most cars are made of steel. Here we can see an Ontario Northland boxcar that has the capacity, load limit, and lightweight stencils, but it's also been stenciled in metric. This was back in the 1980s that they started that practice when we were converting to the metric system in Canada. Here's a similar car to the previous one, but you'll notice that the capacity has been removed. Starting in the mid-1980s, they removed the capacity as they realized that really the lightweight and the load limit combination was similar to the capacity and was no longer required. But there's other things that can influence the lightweight of a car. Equipment such as steel or fiberglass covers on this gondola. Perhaps it has permanent wood blocking or dunnage inside, could also impact on the lightweight of the car. Other things that might influence the lightweight of a car could be a 66 bulkhead flat that's been converted to a center beam configuration to reduce the number of wood blocking that would be required and typically thrown out at the end of the trip. Here's a 52-foot gondola with fixed ends that's had extension sides put on it so that it can be used in wood chip service. Wood chips were obviously a very light material, so the car could have extended sides without exceeding its capacity. Here's a 40-foot TH&B boxcar that's been rebuilt with an 8-foot door. And you can see in the bottom left corner where they've re-stenciled the information just below the reporting marks, this time in white paint, which in this particular case made it a little bit easier to see for this photograph. So when track scales were being considered, the engineering department had to ask a number of questions as to what would be appropriate. How many cars were likely to be weighed at this particular location? What was the maximum anticipated load of those cars? And what was the typical length of the cars to be weighed? Platform lengths could range anywhere from 36 to 50 to 56, 60, and in more modern days, up to 100 feet in length. They'd also take a look at the yard arrangement. Typically, scales were found in larger yards and division points. Would the cars be weighed statically or dynamically? What type of foundation and installation would be required for that scale? Would it have adequate drainage? And what would be the cost of the construction? So let's begin by talking a little bit about static track scales. We see a couple of them here. On the left is the CN Brantford scale house. Has both live and dead rails. The live rails are the rails that are closest to the scale house. Then the ones to the left are the dead rails. On the right-hand photo, we see a CP scale house in Woodstock, Ontario, which does not have dead rails, only live rails. This diagram shows a little bit of what the internal mechanism is below the platform. It's really a combination of levers and knife edge pivot. I'm not going to go into great detail to discuss how this works. As model railroaders, we're really not too concerned with what the mechanism looked like underneath, but it was a very finely tuned piece of equipment. and therefore required constant maintenance. More importantly is what was in the scale house. Here we see a Fairbanks Morse scale at Stelco, our #1 scale house. And you can see as we look across the photo from the upper left is the calibration weight, followed by the balance beam. And the balance beam, there's a rectangular box with a silver handle on the top. By depressing that silver handle, the whole mechanism could slide back and forth on the beam until it balanced. On the far right-hand side is the locking device. Below that rectangle is a punch where a scale ticket could be inserted into a slot, and then by squeezing the handle, it would imprint the car weight onto the scale ticket. Below the desk were a number of pigeonhole type slots that contained different scale tickets. And of course, these operations took place 24 hours a day. You can see the overhead lights to light up the scale house, because it was much easier to keep the lights off in the scale house to be able to see out through the windows. Here we see the scale house in London, Ontario. Very similar design to the previous one in Woodstock, Ontario. Slightly different color scheme in that it's a Tuscan with a gray. This is also a scale that was had live rails only. Here's the same basic design in Woodstock, Ontario, where the windows were painted in a beige. A little bit different angle. You see a train coming up from the Port Burwell subdivision. But what I wanted to show here was the fact that this does not have dead rails. It only has live rails. The thin steel plates that are up against the web of the rail are there to prevent debris from falling down into that mechanism that's below the scale platform. Here's the CN scale in Brantford, Ontario. A couple of interesting things to note here. You can see that in behind the scale house corners, there are 2 ventilation pipes to make sure that there's adequate ventilation down underneath the platform. There's also 2 lamps on poles that would light up the end of the live rails so that the switch crew that was moving the cars could make sure that the wheels were in fact on the scale platform and not overhanging onto the dead rail beyond the scale platform. Something that's not obvious in this picture was there's also a buzzer that's activated by the scale clerk as the train crew's typically standing outside spotting up the cars. When he was finished weighing that particular car, he'd hit the buzzer and they would know that he was ready to have the next car spotted on the platform. Here's the CN scale house at Lehigh. This particular shot shows you the gauntlet style turnout that led to the live rails that are those 2 the rail closest to the scale house. This is also a Canadian National scale house in Hamilton, Ontario, that had been recently rebuilt with a concrete platform and was built on a 1% grade. So as the cars were weighed, they could be uncoupled and they gently roll away from the scale. So this was originally a Fairbanks Morse scale for static weighing. All of that equipment had been removed. It had been replaced with load cells and Canuck electronic equipment. Just a few more examples of scale houses. This one on the Alaska Railroad. was built from corrugated steel panels. Would appear to be under renovation. This one's on the Pennsylvania Railroad in Northumberland, Pennsylvania. Seems quite ornate for a scale house. But you can see those basic features, the chimney or stack for ventilation or heating, and then the lamp above it, the fuel tank to keep the stove warm. This is not really a picture of a scale house as much as it is a yard, but you can see where the scale house was located on the Lehigh Valley in Tifft St Yard in Buffalo, New York. Scale houses were typically located on secondary through tracks in the yard, which made it easier for the crew to weigh the cars and then push them into the appropriate classification track. And here's the scale house on the Pennsylvania Railroad in Chautauqua branch in Buffalo, New York. It does have both live and dead rails, but it is located on, again, a through but secondary track in the yard. This is kind of a unique scale house at Larry's Truck Electric. It was made of brick, but it was elevated. And Larry's Truck Electric is located in a former steel mill complex in Niles, Ohio. But having an elevated scale house gave the scale clerk the opportunity to look inside gondolas to make sure that they were empty as they entered the plant, or to see what type of scrap was coming in. This is the National Steel Car Scale House, which is just outside of National Steel Car on Burlington Street in Hamilton, Ontario. It was a combination brick and steel siding construction. And this is how they would have weighed brand new cars to determine what to stencil below the reporting marks. By the mid-20th century, load cells were starting to be used and replacing the levers and pivots below the scale platform. Some of these were renovated into 250-ton capacity scales. This particular scale house was built of concrete block. So you can see there's a lot of different types of construction materials used. This is Stelco's #1 scale house. It was also an office and a crew lunchroom. It was a wood frame structure with insul brick material covering it. This was actually the general yardmaster's office for some time before it was torn down. This is #3 scale house at Stelco. Again, it was the yardmaster's office, a crew lunchroom. Again, it was built of corrugated steel and had both live and dead rails. #5 scale house was not only an office and crew lunchroom, but also had a change house on the far left end of the building. Again, it was corrugated steel construction, but it did not have dead rails. It only had live rails, but it was a static scale. This is a little bit different type of operation, but just as important to scales. This picture was taken at Stelco's #3 open hearth, and it's a torpedo ladle on the right-hand side pouring molten iron into a transfer ladle. The transfer ladle sat on a small buggy on a type of railway track that moved it from this bay of the steelmaking facility into the next bay where the steel was actually being made. So there was actually a double beam scale here. So one scale weighed the transfer ladle and the little buggy, and the upper one weighed how much molten iron was going into the transfer ladle. You'd question, why would they need to do that? Well, the transfer ladle was lined with fire brick. The fire brick, of course, deteriorated with the heat from the molten iron, which constantly changed the capacity of that transfer ladle. So it was very important to know how much iron was being poured into the transfer ladle, and they could keep track of how that capacity changed, which indicated when the fire brick needed to be replaced. The transfer ladle could be taken out of service. The brick masons would strip out all the fire brick and re-brick it before putting it back into service, as you wouldn't want the fire brick to deteriorate to the point where the transfer ladle leaked. Here's a couple of scale tickets that were used inside of Stelco. They were primarily for weighing scrap steel coming out of the mills. It helped the mill understand how much scrap they were actually producing, because obviously, as you produce unfinished steel, the more of it that ends up as scrap, the less product is going out the door and making money. So it was very important to keep the amount of scrap to a minimum. Here's a Canadian National Railway scale ticket that would record the date, the time, the month, the year, where the car was weighed, and the light weight, any allowances, what the net weight was, and this would be included with the weigh bills. So we've talked a little bit about static scales. I'd like to move on and talk a little bit about dynamic track scales, or what's called weigh in motion track scales. On the left, you can see the Canadian Pacific Alyth Yard in Calgary, Alberta. It's a weigh in motion hump yard with retarders and 48 classification tracks. On the right is also a weigh in motion, but this little scale house was weighing the scrap as it was being pushed into the number 3 open hearth floor before it was charged into the furnaces. But this is an uncertified scale, so it was not under the weights and measures. It was merely to keep track of the amount of scrap going into the furnaces. If you're not familiar with load cells, this is what a load cell would look like in a typical weigh in motion scale. It's able to measure incrementally small changes as the weight pushes down on the pad. Probably the biggest weigh in motion hump yard in the world is at Bailey Yard in North Platte, Nebraska. This particular yard had 114 bowl tracks as cars rolled down the hump. So at the top of the hump, a switchman would uncouple the cars. The cars would roll over a scale, weigh in motion, move through the retarders, and then another person would determine which classification track that car was destined for. This is the Elgin Joliet and Eastern Hump Yard weigh in motion scale in Gary, Indiana. So you can see the cars are right at the top of the hump, about to be uncoupled as they roll down through the scale and through the retarders into the classification. Again, this is a weigh in motion type scale, and the scale itself looks like just a big desk with some electronic equipment on top of it, but it was able to detect the flanges on the wheels, so when to start and when to stop weighing each car, and then record that information into a printout for the scale clerk. We used exactly the same piece of Amatron equipment at Stelco's number 4 scale, which again was an uncertified scale. It had a 24-foot scale rail, but it was primarily used to weigh gondolas with scrap steel. Let's talk a little bit about scale test cars. There were several manufacturers that manufactured scale test cars, such as Fairbanks Morse. Many of them were cast steel, or they were fabricated from steel plate, but many were also converted from older pieces of rolling stock that had been retired. Typically, scale cars don't have any air brake equipment, so they don't have a cylinder, a reservoir, or a control valve, but they do have brake shoes with a brake wheel, so they can be held in position during the weighing process while they're testing a scale, but there is no active air brake equipment, only a train line from one end of the car to the other. Why didn't it have air brake equipment? Because the brake shoes could actually wear down, and as the brake shoes wore down, it could change the weight of the car. The final test weight of each car was typically set with 50-pound pieces of pig iron, so they could open the top of the car, adjust the weight, and then close it back up again and typically lock it. Repairs could only be made by an authorized car inspector or weigh inspector. And scale test cars are typically moved at the end of the train, just ahead of the caboose. I've also seen times when scale test cars were actually loaded onto flat cars and moved on the flat car. Here's Stelco's scale test car. It was manufactured in our car repair facility. It had an 80,000-pound tear, and we used that to test the scales that were certified in the plant. This is a really unique scale test car, 57,000-pound tear weight for the Bangor and Aroostook. And what it appears to be is a Blomberg diesel truck that they've added a box to the top to put those pieces of pig iron to bring it up to a specific weight of 57,000 pounds. This looks like it might be a really interesting little kit bashing project if you're considering building a scale test car. These two cars are on the Delaware and Hudson in Pittston, Pennsylvania back in 1976. The one to the left was an 80,000-pound tear, and the one to the right was a little bit smaller at 50,000 pounds. And they were coupled just ahead of the caboose. This is a Penn Central scale test car. I couldn't find the actual tear weight printed anywhere on the side of that car, nor could I find any further information on the internet, but it appears to be one that might be in about the 50,000-pound tear weight range. Looks like there's riveted construction on it. I think it was a fairly old one. Well, actually, I can see it from here. Built in April of 1906. Here's another pretty old scale test car for the Canadian National, and fairly lightweight at 60,000 pounds. There's a few more Canadian National scale test cars. Again, no air brake equipment, but it is equipped with a brake wheel, and it does have, of course, brake shoes to hold it in position while doing testing on the scale platform. This particular one is relatively small at only 31,000 pounds tear weight. This is a cast steel version at 40,000 pounds. It was purchased by CN in 1943 from the Pennsylvania Railroad. Here's a little bit heavier version at 80,000 pounds. You can see the little door in the side where they could add pig iron to bring it up to the appropriate weight. As I mentioned earlier, some of the older rolling stock that was retired was put into scale test car service. This is originally an ore jenny that had been converted in 1990 They would have had to put a roof on it to control any debris from falling inside the car. And since it's set at a 46,600 pound tear weight, they must have also added some pig iron to its light weight. Its car was retired in 1994. Here's a covered hopper that CN has converted to a scale test car. It has a much higher tear weight of 214,700 pounds. It was originally converted in 1991 from a slab side covered hopper, but was retired only 3 years later. They also rebuilt some cylindrical ore cars into scale test cars. Again, this is a pretty heavy duty car at 224,740 pounds, but it was rebuilt specifically for use at Macmillan Yard in Toronto. This CP scale test car was built in 1916. It's a relatively heavy one at 60,000 pounds, but you can see it's a much older design. This one's similar to one of the CN cars we just looked at 80,000 pound capacity in London, Ontario. This particular day in question, they were just getting ready to test the scale. CP also converted some cylindrical slurry cars into scale test cars. Again, fairly heavy at 254,500 pounds tear weight. The car was converted in 1990. I'm not sure if it's still in service. I couldn't find a retirement date for it. This is an interesting conversion too. This was originally booster B1, which was a booster that ran behind diesel locomotive switchers, specifically for their traction motors to increase the tractive effort of the switcher. And at some point, they decided that was no longer necessary, and they converted it to a scale test car of 200,000 tear. Here's a Lehigh Valley car that is in the process of testing the scale. I think what's interesting about this car is it appears to be built on perhaps a four-wheel passenger car truck. So again, there's lots of opportunities for some kit bashing here to build a scale test car for your home layout. This one was 76,000 tear weight. Scale platforms were typically tested at least annually to be certified, and typically in 4 different positions. So they would start by putting the car at the far left end of the platform, weighing the car, pulling the car back to center right, weighing it, moving it to center left of the platform, weighing it, and then to the far right and weighing it again. Theoretically, all 4 times, the scale test car should weigh 76,000 pounds, but that wasn't always the case, and that would require the scale mechanics to go down into the pit below the platform and make adjustments. So, modeling the prototype. So, almost any layout that depicts the 20th century could have a railway scale. And there are numerous scale house and scale test car kits that are available, but most of those prototypes could just as easily be scratch built or kit bashed from other materials. Keep in mind that not all track scales require dead and live rails. So if you're not interested in changing your track, you don't need the dead rails. Use it as a live rail only. You really only need a short passing siding somewhere in the yard with a narrow piece of real estate. And there's been numerous articles written about track scales I suggest that if you do any research on the internet, try not to use the word scale. Try to use the word weigh instead, W-E-I-G-H. I found that most times when I used the word scale, I got a lot of hits on things like N scale, HO scale, etc. So the word weigh seemed to work better in a search. So let's just go back and talk a little bit about some of these scale houses that we've introduced earlier and take a look at how they could be modeled. This is the CN scale house in Brantford, Ontario. It's a very, very typical CN scale house design. You can see that the corners at the front have been chamfered to 45 degrees to make it easier for the scale clerk to see the ends of the car or the switch crew that's standing outside in all the inclement weather, spotting the cars. This particular scale house was located across from the station in Brantford, Ontario. Again, on a secondary but through track, which made it easier to weigh the cars and then classify them into the yard. Here's a sketch done by Pete Moffett years ago when he produced a resin kit for this 125-ton capacity CN scale house. It came with not only the lamps, but also the ventilation pipes. There's also blueprints available for this particular scale house design for the 125-ton track scale, which has a lot more measurements on it. It might be easier from a scratch building point of view. So this is a small diorama that I built that includes the CN scale house that was produced by Pete Moffett years ago. It has both the live and dead rails. Elgin Models has just recently introduced a 3D printed version of the CN scale house, which includes an interior with the scale beam and a stove in the back corner, although the stove's a little bit hidden in behind the beam. But it's not a bad rendering when you consider that it's only visible through the windows. The Toronto, Hamilton, and Buffalo had a scale house in Hamilton, Ontario, and in its Aberdeen Yard. It was kind of an unusual design, and that the roof was pitched toward the scale, which kind of surprised me when I first saw pictures of it, because I thought all the rain and snow, etc., on the roof would have dripped off into the scale mechanism. But in fact, that is the way it was. Again, it was located on a through secondary track at Aberdeen Yard. Quite a ways really from the busier part of the yard down by Aberdeen Avenue, or the car shops. There were plans for this particular scale house published in the TH&B Historical Society magazine, The Focus, a few years ago, along with an article about not only building this model, but other TH&B scale houses on their system. So here's an HO scale model that I fabricated for the Homes Club in Hamilton, Ontario, with that unique sloped roof toward the track. This was not a particularly difficult model to build. However, those 4-pane windows are not readily available and have to be kit bashed out of a couple of other Tichy products. This is a Norfolk and Western scale house in Columbus, Ohio. This photograph, although undated, I believe was probably in the 1960s when it had both live and dead rails. My son models the Norfolk Southern Sandusky District on his home layout, and I thought, well, it'd be interesting to add a scale. Well, he didn't want me to tear up the track to install the scale house, So we ended up not putting in the dead rail and making it strictly a live scale, live rail scale only. So I thought it would be important to put an interior because it sits right on the front edge of his layout. This Fairbanks Morse cast metal piece is actually available through Woodland Scenics. They produce a very small kit for an outdoor scale, which has a little canopy over it, probably more suited to southern climates. But inside is this piece that represents the Fairbanks Morse scale on a platform that I used inside the scale house, which is visible through the windows. And then I thought, well, we should add a desk and a chair and a filing cabinet. So I built those little pieces to fill in the other details. I also thought it was important to have a scale house at the Stelco scene on the Homes Club layout in Hamilton. So I scratch built this little brick scale house, which is very similar to number 2 scale at Stelco. It was designed specifically to weigh scrap on its way to the open hearth. You can see the coke ovens and the number 2 byproducts plant on the left-hand side, and the Stelco switcher that's moving the quencher car from the coke ovens down to the quench tower in the middle right part of the photograph. Bachmann makes a pretty nice looking cast steel scale test car. It represents an 82,000 pound tare weight car. So how could you enhance your railway operations to include a scale house? First off, your switch list could include comments such as to weigh cars before shipping. You could add a car clean-out track. You could add a held car track to be included for cars that have to be reweighed or the paperwork adjusted before shipping. And you could update the reweigh dates on some of your rolling stock. If you're using car cards, as you note on this particular bill of lading, it says that these water heaters were loaded at Ream Canada in Hamilton, but the car must be weighed before it's classified. If you're using a computer-generated type switch list, there's always room to add additional comments. This indicates that all loaded cars, after being switched out, have to be weighed before they can be classified in the yard. So what would be a typical yard arrangement for your scale house? Again, if you can find a short double-ended piece of track, you need a very narrow piece of real estate to put the scale house on. If you want to add the live and dead rails with a gauntlet turnout on either end, that would be great. But if you don't have room to do that, then by all means, model it as a live rail scale only. There's also a car cleanout or a held track in this diagram located directly behind the scale. That cleanout track might be for cars that were weighed and found to have excessive debris and dunnage in them that would have to be taken out by laborers to clean the car out, or perhaps cars that were held because the paperwork was not correct. Here you see the car cleanout tracks in Nelson, BC, where the laborers would remove the debris and dunnage from the cars. The next couple of photos were modeled by Bob Fallowfield. Some of you may know Bob from his Galt subdivision Facebook page, but Bob often changes the stenciling on some of his cars to represent the 1980 era. So in conclusion, track scales were very common in larger railway yards and most division points. Major industries often had their own scales, such as steel mills, for example, but also things like mines might have their own scale, and other large industries. Of course, not all cars need to be weighed. Some are shipped based on estimated weights, carload rates, or minimum rates, as it was determined by the freight agent for the railroad. Very few model railways include this important piece of equipment. So if you're doing some internet research, companies like Buddha Equipment, Canadian Scale, Fairbanks Morse, House Scale, and S.E. Barker would be names that you might want to see what you can find out about them. So I'd like to thank you for watching.